Hello.
Bună ziua. Hello.
Welcome back to...
Hello, good afternoon.
Hello.
We'll wait for the other one to join and we'll start.
Yes, it's our last course.
And then we'll see all the paperwork.
The results.
The results, yeah. And the evaluations.
Bună ziua, domnul Sterean. Am o întrebare, nu știu, până când nu s-au conectat, adică nu vorbesc engleza și de aceea profit de momentul ăsta ca să adresez o întrebare. Îmi spuneți, vă rog, aveți ceva materiale în limba română care aș putea să studiez adăugător?
Încerc să vă trimit ceva, dacă e, dar cred că avem contactul noastră, nu?
Da, sigur.
Ah.
Sunt, da. Vă mulțumesc mult. Dacă este posibil, chiar mi-ar fi de mult ajutor, fiindcă cu engleză stau prost. Știți că în Republica Moldova suntem cu rusisme mai mult și cu...
Da.
Da.
Nu e problemă.
Mulțumesc.
Ținem legătura și încerc să vă trimit chestii.
Mulțumesc.
Okay, let's. Oh, should we still wait for a little longer? Another 4 minutes. Mhm. Okay, let's start it. And we will discuss today the topic of today course. It's post-production and how we can do the things look different in the post-production stage when we prepare the products, either photograph or video, to be screened or printed. And nowadays, the printing photographs is not anymore a very useful approach, because all the photographs, except the one they've been printed in the magazines, that are seen on different displays, laptops, smartphones, and so on and so forth. So when we open a photograph on our laptop, of course, we can afterwards process it and change it according with our intention when we made that photograph, or we think about how that look can be achieved after all in the post-production stage. So the post-production, it is a very important stage, because the final look of the product, it's achieved in that final stage of the production of the image, either photograph or video. So talking about both kind of color correcting image, of course, in photograph, it's kind of easier or different approach, because the levels and the way of influencing the parameters of the photographs can be, of course, differently approached. So you have in just share you. An aperture software, which is usually used to change the looks and the parameters of the photographs. And we have here adjustments, a lot of adjustments. and we can add any adjustments we wish. If we want to go on black and white, you can just go on those parameters, or just getting back to how it was. Just if you highlight it, it goes to black and white, and then you can adjust the levels and the contrasts according with what you want to make it as wish. So the main parameters which we can influence here, it's of course the color temperature I just told you about. When we change the temperature of the medium, and our references is we want to go warmer or cooler. That's one of the approaches here. You can go on a picker and see how much it is as a neutral way, and then we can change that in adjusting it again on let's say on a cooler temperature. You can also change the tint. This is the balance between magenta and green, and of course work on the exposure and bringing up or down the blacks, making more dense, or the other way around, and work on the brightnesses and all those kind of parameters here. Again, on the contrast and definition, saturation, vibrancy, you can also do whatever you want, and then make it different tints on midtones, highlights, and blacks. So the blacks, as you can see it here, are very cold. Yeah, you can make it greener or whatever, or neutral. So it's very easy to change that appearance just by moving around with those parameters. So of course you can add also effects in color, like if you want to do, there are kind of looks you can achieve very easily if you want to go on cross process, let's say it. And the cross process, it's a very intense process, because it's involving all those parameters which usually we're not seeing in as you can see, there are different looks on how the color is going to be rendered just by choosing cross process 1, cross process 2, vintage look, sepia, which is an old kind of look, and so on and so forth. So just overlaying those kind of values, it will make the thing looks, of course, back to how it was, or change the appearance of the things. We can also load to the library here and do whatever you want with those two kind of looks. I just use it. And of course, the same thing happens here. We can adjust the contrast, make it more contrasty. here you can see the histogram of the photography, and as a saturation and vibrancy of the colors, you can also change that and select this color here and get back to how it was without enhancing any areas here. So just for the photography sake, it's in a way easier to do the enhancements and changing the appearance of the photographs. You can also make some smoothing up or repairs on different parts of the photography, and that is of course easily done with this tool, repair or whatever. You have to define the source, and then do this thing, like smoothing the edges, and so on and so forth. Anyway, there's a lot of features here in aperture, which is from the Photoshop suite. I'm not sure how easily achieved it's this software, but there's some free software as well. And one of the examples which I want to getting into discussion now is the Davinci Resolve, the one I just already use it in my video because Davinci Resolve, it's an easier way of editing and also color correcting whatever you want to make. So I'll try to get into the let me just import something here. Okay. So what we're gonna see here, it's wait a second, I just share the screen. Of course, you can review and see the video which is already loaded on the platform. We have here all kind of correction tools. You can correct, let's say, on this lower part here, we can go and see how the project was shot. So we have the settings here. This was a 6K Blackmagic camera, and the clip, it is, you can have all this informations here. Yeah, how the color temperature was choose, and how the exposure can be also changed from this parameter here. You can go and change the values very easily just by clicking on this camera raw, because this is it's a camera which actually shoots on RAW format, and that gives us the possibility to do all the correction we want to make it. So here on the right, you see the levels on the three values RGB, and by just moving the levels up or down and bring it lower, we can see how the picture is changing. So the black levels, which has to be somewhere here around 5 to 10, it's the level of those three RGB values, and all those values can be changed and then balanced or unbalanced if you want to make it more bluish or more reddish. The atmosphere on the shoot or on the film, you can just adjust it from here. So we have those three values which can be adjusted on midtones, shadows, and highlights. By reducing the highlights, the atmosphere looks a little darker. Getting up on the highlights, you see the brightness is going up, and then we can also change the values on on each channel we want to do, or getting back on this tool which says on overall look, changing the tint or the values on highlights, midtones, and shadows. So we have those three sections on which we can change individually the value and the color on the highlights. So we can go brighter on the highlights here and change the hue by just moving it to the orangey red or cyan blue or greenish. You see the levels here on the lower right, they're changing only on the highlights areas. So let's say we want to make it a bluish atmosphere. We go on the highlights, then we go on the shadows, and we do the same thing here. We reduce the red on the highlight, on the shadows, and then the shadows, they're gonna look bluish as well here in the midtones. Yeah, so in the midtones, of course, we feel it differently. As an example, let's look how it was without any corrections and how is it now. Of course, there's a big difference, and what I'm trying to make it here is how the feeling of the take and the atmosphere of it can be influenced by how this lens flare will change this feeling. So getting on a different camera, which I used inside this soundstage, and I showed you yesterday some examples of it. Let's take, for example, this one. We can also do the same adjustments as overall atmosphere on lift gamma gain, which influence again the brightness, the midtones, and the blacks. Yeah, we can reset it from here, or just do it on shadows, midtones, and highlights, and on the levels individually. Lift gamma gain like here, but on different channels, on brightness, or here. This is more effective because you can see it immediately how the hue on the blacks it's raising higher, and how in midtones the same thing will happen. You know, so in a way we can see how if you want to make a bluish overall, if you look at the curtains here, which are very neutral warm now, we see immediately how this tint is changing on the bluish. And if we want to do that more abruptly, we get on the green and on the red, and that makes it even more obvious, the tint of the cyanish bluish in the highlights. The highlights means also the light effect, which is getting into this space, and it's making the differences between how it was and how is it now. Also, on different and special moments within this frame, we can try to recover, let's say, some of the informations in the window here, and that means we have to bring it down a bit and feel how the brightness of the curtain is influenced, and then use the gamma to make it a little more contrast, and then bring down the blacks to have an overall contrast, and how the atmosphere is changing, I will show you immediately. It's just an adjustment of specular highlights and the areas where the whites are clipped here in the window, in the curtain, which are adjusted here. So all the rest, I tried just not to influence too much, but we can also do whatever we want and make it adding, let's say, nodes here, and do different adding a vignette, let's say, and this vignette can influence the overall mood. By making more like an atmosphere all around, and then we can add another node and do another vignette, and try to make it, let's say, just for him here. Come on. Okay. So inside those areas here, we can influence the way of how the vignette it's making the effect, and you can see the differences here on the first one and the differences here on the second one. So this one is just adjusting the overall contrast only on the edges, and the other one it's making it more abstract and adding a little more brightness here on the guy. So these small things are just to adding a little more mood on the frame we want to correct. Sorry, but I need to get to this call. They will call back. Okay. So, of course, the overall look, which is the most important on the video or on the photograph we're shooting, it is just the next step and the final stage on how we finish the movie or the scene we shoot, or the photograph we also shoot it and then prepare it for delivery. So we can deliver that photograph for printing in the magazine, or we just put it on the website, on our website, or just on the internet, and everybody will see that picture or video on the display we think it for. So the display, of course, is very important, because the differences between how we watch and look at the photograph, which is printed, and how we look and see the same photograph on a computer display, it's totally different matter, and it looks a bit different, because it doesn't have the same transparencies, doesn't have the same densities on printed. Of course, it's more dense than in a computer screen, when we can adjust the brightness and the contrast of the screen, and of course, the environment which in which we're seeing all those photographs, it's gonna influence and affect the contrast on the screen itself. So sometimes, of course, this difference, it's fairly big between two photographs, screen and printed, and the quality of the pigments, of course, it's also different, and it's depending on how the screen, how big, how high the quality of the screen is, and how the format of the photograph it's interpreted on this screen we see the photograph on. So anyway, the differences between RAW and compressed formats, it's of course the main and the biggest difference is in the size of the file. So the files, of course, are fairly big. The one I just showed you, the Blackmagic 6K, it's almost 2 gigabytes on. It's a very short moment. It's like 20 seconds or 30 seconds. Otherwise, if you want to make it smaller, you have to apply a compression algorithm. And the compressions algorithm are different in the photo and video, of course, but they are both divided in lossless and lossy compression. Lossy compression means when we apply a compression which makes the file very small and all the information is thrown away. All the different information which is not possible to be kept in that codec it's been thrown away. Lossless means it's a codec which keeps partially most of the information, and the size of the file it's not that small, so it's bigger than compression. When we use lossy compression, the difference in a photo, it is like we're shooting RAW and we have 24 megapixels and megabytes photograph, and then compress it to a JPEG, and the JPEG, of course, it's a very small. The difference is, of course, it's the details and how the color is rendered in between those formats, because on the RAW format we have usually a color depth and the bit rate, which is 14, 16 bits, sometimes 24 bits per channel, which of course means a lot of information about saturation, intensity, and hue, which when we reduce these values on the information of 8-bit, let's say, which is bit per pixel, like 24, because there are 3 channels, 8 bits each of it, we get to the 24-bit overall information, which is, of course, much reduced than having 16-bit per channel on original RAW file. Sometimes the reason to do this compression, it's of course the size of it and how we keep the information. It's depending on how much space or which kind of archiving situation we want to apply, because sometimes just put the information on a hard drive doesn't assure us to keep that information alive for a long time. So a long time archiving, it's a very special issue, and it's very delicate those days, because we have a huge amount of information which sometimes we want to keep it, and that value and files, the size of the files is becoming bigger and bigger. So remember, if you had that experience in time, the processing power of the computers like 10 years ago, which was like, I don't know, a couple megabytes, and now we're talking about terabytes and values on processing and storage, which are huge. Therefore, if you want to really keep that if you want to keep that value without any compression, we have to have in mind this dimension of the files which we want to upload it and keep it on the hard drive, which sometimes it's very difficult to make. On the video, it's also a very delicate situation, because we recently started to shoot on very high resolution cameras, very much higher than HD, which is the standard for television signal. And we use sometimes cameras with 8K resolution. The 8K resolution, it's of course a huge resolution for what we expected to see on the TV screen or on the cinema screen, because the standard, the screening standards on television and cinema, of course, they've been changing all over the time. But most recently, we have for cinema, we have 2K and 4K resolution. And for the television, we're going extremely high, like 4K and 8K resolution, which is huge, and it's not really necessarily, in my opinion, and I'm not the only one who says that, because the eye can't really see those kind of details, and it's useless to concentrate on this stage of capturing and then delivering on I don't know, internet or live stream such a big amount of information only because we want to use a 4K or an 8K channel, which doesn't really do anything more or adding any quality to the image, because we're unable to see the differences between 2K, 4K, and so forth, 6K, 8K. Just to have a little example of how this differences is related with the values of the resolution. You have to have in mind, I will show you right away. So at the beginning, when the digital revolution began, and all the manufacturers and people involved in this industry started to saying, okay, we need to change the TV resolution because the standard resolution is too low, and the standard resolution is the little square here on the right. That's the standard resolution. And we need to change that thing with bigger resolution because we need that thing to be higher quality. The differences between this small square here, which was standard definition, the analog television, which today is called 480p, which is 625 or 675 or 525 lines per square for a screen height. So this is the 480 on today digital definition. And the next one, which is 720, of course, it's double the resolution of this. HD, which is 1920 by 1080, it's for the resolution, the 4 times the resolution of this little square here. And then the 4K, it's 4 times the resolution of HD, and so on and so forth. 8K is the 4 times the resolution of the 4K. So by doubling the number means the 4 times more resolution, because we're talking about doubling the horizontal resolution and vertical resolution. So we include on this square here 4 little 4K squares in the 8K, and 4 little HD, which is very close to 2K in a 4K, and so on and so forth. So those are the standards on the 2K, 4K, 6K, and 8K. And the differences between 2, 4, and 8 are 4 times the resolution. And between 4K and 6K, it's doubling the resolution, which can be shown or displayed on the screen. Talking about this need to have higher resolution on the displays, like televisions at home, like all the let's say the companies which are doing live streaming are pretending, like Netflix, Amazon Prime, and Disney Plus, and so on and so forth. They're saying we need to bring to our consumer the highest quality, so we need to deliver a 4K signal. A 4K signal, of course, sounds very impressive, but as I said before, there's no need to have bigger resolution than HD, not for now, because the codec itself, it's keeping all this information in the screen, and we're not able to see such a tremendous difference between HD and the 4K, which is actually a quad HD format. So getting back to live streaming movies which are done by the internet, and of course you have to have that internet stream to assure that change of data, which is also impressive and is pretty high. The quality which is also screen on our television, it's not very different than in between. If you compare 4K to HD, is not such a big improvement. The big improvement was indeed when we changed the definition and the resolution from standard definition, which was 4 times lower than HD, to this today's standards, which is a full HD 1920 by 1080. Therefore, this kind of stupid race of bringing up higher resolutions on TV screens doesn't change that much the perception of that picture, because if actually seeing very big or very well this difference, you have to be on a different distances to the screen. So our today recommendation for seeing or watching a TV in your living room at home, it's 4 and 6 times the diagonal of that screen. 4.6. 4.6, the diagonal of the screen means that if you have a big television at home, you have to be at a fairly big distance to the screen, not so close. And I'm talking about the HD resolution. So if you have a screen which it has 1.2 meters diagonal, that means you have to be at least 5 meters distance to that. Sorry, it's 3.6. 4 meters distance to the screen, which is this is a kind of impressive distance to that screen. Of course, one of the reasons being that far is not only the resolution, it's also the brightness of the screen, because if the space we are watching the television in, like the living room or the bedroom, it's too dark, the eye, it's compensating that contrast, and in a short time, we're seeing the colors, and the contrast is different on the screen. But that's a very subtle change of this perception, and it's just for the professional colorists to have in mind when they do the color correction for the movie. So seeing the difference between HD and 4K, because that's the final thing which I'm gonna tell you now, you have to change the distance, the viewing distance to the screen. And the viewing distance to the screen means that you're not having the distance to the screen. You just have to be at a fourth, so 1/4 of the distance to the screen. So for the 4 meters distance, when you watch HD resolution television on a 1.5 diagonal, you have to be as close as 1 meter to the same screen to see the difference between a 4K and an HD. So I doubt that any of you, if you have such a big screen at home, you'll be sitting in that close at 1 meter just to see the difference in between HD and 4K. So it's very doubtable, this race, which I already mentioned, of chasing higher resolution and displays as big as we can do it, just because the manufacturer, they're trying to sell bigger screens with bigger resolution, and the marketing ad says about it's bigger, we have brightness which is bigger than before, we have resolution which is bigger than before. So look, those are all the reasons you have to buy the new one, and forget about the old screen, and throw it at the garbage. So yeah, there's a lot of discussion about this, and it's a never-ending story in how we have to change the displays, because we have also those kind of differences and the quality. Okay, let's have a 10-minute break, and see you in 10 minutes. See you soon. Okay, I'm back. Sorry. Okay, so getting back to this stage of how we deal with the size of the file and what we want to show to this. It is, of course, a matter of how the information is rendered. And this information is rendered in a different sizes because we process the information according with the bit rate and the resolution we have it on the camera. So of course, if the resolution, of course, is bigger, we have this different size of the files because this is very dependent on how we see the details in the picture. So this is kind of very graphically explain the differences between 1 bit, 2 bit, 4 bits, 5 bits, 6 bits, and 8 bits. Gradient of informations on how we see the brightness, let's say. So when we have 1 bit, we have just white and black. Then we have different gradient on 2 bits, 3, 4, 6, and 8. So of course, in the color, that's even more complicated because we have to cover different hues. So the brightness, which starts from black to white, and different hues throughout this compression. So if the compression is very big, of course, and sometimes we see that in the video and also in the photographs, it's that effect which is called bending. Bending means in a very uniform tones or colors. The colors itself is not shown as a uniform hue. It's just we see some bands from different, let's say, densities and hues of that colors, which is not uniform on the whole the surface. So this is one of the, let's say, defects on compression. When the compression is too big, we lose the information on colors, hue, and saturation, and that in the video signal, it's going to that banding effect on the video. There's also a lot of different effects or defects on the video. Most of them, they are usually achieved because the compression is too big or the compression is wrong applied. And one of the situation which I already told you, it's this effect of poor resolution in the color and the contrast. So banding is one of the defects, and the other one it's aliasing or moire, and those kinds of different picture defects are, of course, influence the way that image is looking, and it's seen on displays we're seeing on. Well, let me just check something here. I think I already showed you the, there's a, Mhm. So some of the those concepts are in that link I gave you with the Cambridge in color. And I will share that again with you because it's very in-depth, explainable, and explains how um, the compressions on monochrome, VGA, XGA, SVGA, whatever, it's shown a different range of colors, and that's the bit depth on the pixel compression, let's say. So the same as we have it before, and I showed you in the bit depth and color depth, it's here very nice shown, because this is what I've told you about the bending feeling, those kind of lines here on the colors. It's called bending, and that's because it's a poor color rendition on how those colors are being shown. So, of course, if you look at the bit depth here, 24 bits per pixel, which in photographs it's approximately at the limit of the value, which is this one. In video, it's enough to get this 16.7 million colors, because it is kind of here one 16.7 million colors, different colors, because we have 8-bit signal on RGB, which means 8 bits on red, 8 on green, 8 on blue, which altogether comes to 24. So this is just for photo compression and bit depth, which of course it's a totally different values when we talk about processing and keeping the how we choose to do the compression. So again, on this kind of details and texture, we want to keep it on the final format. Of course, we have raw format, which are very big, and we can then export it on TIFF or JPEG. And of course, the TIFF is wider than the JPEG, which is a tag image file format, but it's also bigger than a JPEG, of course. And if you see as a compression, so 100% compression, it's similar with this. I will just make it a little bigger. So as you can see, it's just on small details, you can see the difference between uncompressed and compressed. So there's a very interesting tool here, and it's very easily to work with, and it's showing how different approaches in how to compress the format from RAW to TIFF and from TIFF to JPEG. Of course, it's as I told you, some of those formats are lossless, which are not losing that much, and JPEG, like here, it's a lossy compression. So lossy compression is the one which throws a lot of information and keeps just that part which is relevant for the viewing. Yeah, again, it's lossy and lossless. Lossless, it's the one which assured some of the most important parts of and the details from the picture are still kept in the final image. Okay. Not sure if I'm getting back to that Resolve. It's very easy to download it from their site because it's free. The version of that I will just put it again here on the chat. It's from their site, and you can just get there and download it. Oh, sorry. I just sent it to. Okay. So you can find it there. And of course, you need to have some processors and speeds on the computer to move that software. Okay. Again, because when we trying to print and trying to make it look good, some of the photographs we're processing, we look at again another tutorial here on the camera in color, and we're gonna see how the color space and the working spaces for colors in digital photography are used to have a wider gamut or not such a wide gamut. So Super RGB versus Adobe RGB, which are two different color spaces, are shown, of course, differently because the gamut means the color space means that part of that space in the horseshoe graph I showed you before, and that thing, it's dependent on how wide is that space, and also on a printer how wide it's the gamut which the printer is able to cover it. So sometimes in on those two different spaces, which Super RGB, it's a little thinner and smaller than Adobe RGB. So the white one is the Super RGB, which is a little smaller than the other one. The black line, it's Adobe RGB. And here we can see how even the printer we're gonna use for the photographs, of course, it's influencing the way of redoing the colors and the contrast in the final product. So here, of course, as a color gamut, it's a wide or narrower gamut on both color spaces. The luminance and how those colors are influenced by this brightness, of course, it's changing the the saturation of the colors. As I already told you, when we change the luminance of the medium, the value of the hue and the saturation is changed, and it's decreasing as the luminance is getting to higher levels. Of course, when we compress the signal and the image, it is the same as I showed you before when we have not such a big bit depth on colors, and we have to compress some, which is a very large gamut, which brings all the colors and the brightnesses of this, let's say, hue. We want to extend it or compress it into from the small gamut to a different value. And the same thing happens when we expand some of the information we already compressed it before to a different values or sizes. That's why when we print photographs, the resolution it's very linked to that DPI value, and the value which is let's say a standard for a print, for a text print, not for a photograph print, it's 300 dpi per inch. And otherwise, if you want to have a higher quality, you have to go to double it, this dpi value, to 600 if you print color photographs on the magazine, let's say, on glossy. And sometimes when you go to the art reproductions, like art albums, you go even higher than 600 dpi, which means you need to have enough information to work with and also compress it not that hard in order to have enough information in the photographs you processed. Okay. What else? This is again about composition. It's not such a interesting thing. You can check it out by yourself to this site and tutorials. So, as I told you, of course, one of the biggest and the most important thing in processing is to have enough information and bit depth in color and brightness and all those parameters we want to adjust it, because otherwise not having enough information there it's going to limit it, our choice to get to that level we want to use it. So having those kind of big values on from the camera or from the compressed image, it means we have small chances to get sooner to a noisy image or to a less noisy image. The noise, of course, it's also a value which can be very well influenced by the ISO setting. And if we shoot on high ISOs, of course, the possibility of having noise in the picture is very high. It's getting higher and higher, because when we increase the sensitivity of the camera, that means the sensor it's over flowed by the signal, and the exposure on the sensor is not so well done. So as an example, which is very, let's say, visual approach, we have again this explainable tutorial on this concept, signal to noise ratio, how the details in the shadows can be defined or not defined, because the differences between those details which are on the shadow part of the dynamic range value are visible or not. So as low this signal goes, that means we're going to have noise and not any details there. So that's the main problem, of course, when we want to keep that areas clean, not noisy. And this kind of noise, as you can see it here, can be very bending, like some stripes, or random noise, or just pattern noise. The problem with the digital noise, it's the structure of this noise is not overall the same. It's different because it's because of the structure of the sensor. It's tinted in red, green, or blue, and it's randomly spread on that underexposed area. And sometimes it's very tricky to deal with it, because if you go too bright on the picture, you can start seeing that noise on the shadows, of course. So you can't really brighten up too much or change the contrast, because using the contrast and the brightness and change the level of the blacks in the dynamic range of the camera will bring that noise to the image. So it doesn't look very well, and that's one of the reason why we try to expose very well the image, even if it's a photograph or a video, and then to have enough space to work around with the picture after all. Okay. If you have any questions, I will be happy to. Okay. I will show you now as an example of how we can try to, let me get back to Davinci, how the level of the noise can be annoying or not. We'll look at this picture, and then on this picture, which is of course very dark. Let me just turn off this light here. So as as a space and the mood we want to express in this picture here, of course, this atmosphere here can be very, let's say, credible. Yeah, it's interior daylight with some atmosphere, and the relation between those two guys is very realistic. Therefore, if we change these levels and we want to recover what is in the darks, and we can see how the signal is crushed here, because that's the first first part. We can see it in between those two images. Yeah, here the image, the signal is more spread from the whitest white, which is 1023, which is the peak level of the whites, and the 0 is the black. That's the 10-bit signal, 124 levels from 0 to 123, and the signal is spread all around the values here, because it's, let's say, for the atmosphere we want to make it here. That's the way of doing it. Otherwise, on the second one, of course, we have all those continuous lines here, which show how the blacks are crushed. We don't have any much information here. Yeah, so when we see a line, even if it's in blacks or in the whites, because on the other one we had, you'll see here, not here, the brightest one here. Here we have this line on the highlights. You can see here. This is the line because of the brightness of this lamp here. So the line here means we don't have any more signal there. We can't really recover anything there. So as soon as we can bring that down, we can start seeing noise in the highlights, or in the other example here, seeing noise in the darks, in the blacks. So trying to get this a little more brighter, we will start to see the noise. And the noise is on those areas here, and here, and here. Of course, being that small, the screen here, we can't really see it, but on a big screen, even on a television, you can easily see this. You can easily see this difference between how the blacks are shown here or here. If you want to recover, that's the main topic. If you want to recover the blacks here and make this scene looks brighter and more like daylight thing here, we might think that's affordable, acceptable, but it's not that that's correct, because it does look, let's say, similar, but the feeling is of course different, and this is just because the material at first was very underexposed. Yeah, and sometimes being that underexposed brings us to that situation within which we can't really get anything out of it. So sometimes it's better to, and for certain cameras on the certain codecs or color spaces, it's sometimes it's better to overexpose a bit, like here, and then compensate on the color correction and timing, and make it more moodier or different look, instead of having this on the opposite, having very dark and trying to recover the details in that thing. So same thing here, as you can see it, but still it looks a bit different, because here, if you want to recover the some parts of the scene and get close to that dark level, doesn't look the same like, let's say, which one is here, when we're trying to recover that thing and make a little brightness, and then because the level of the noise here is shown by this line, which says that's a clip, that's a block. The signal is blocked here. We don't have any details in between those parts here, and that means we can't really lift it or make it look like in very well like before, even if your impression is, well, it looks pretty good. Well, it doesn't really look very good if you look at this one, which was also adjusted. It's a totally different feeling, of course. This one was the 14. So 14 versus 2 or 3, it does look different as black levels, and you can see that in the details here. So the blacks are they're having like a texture. It's a very, not very deep blacks, but the blacks in here are different than 14, which is here. Yeah, you can see the blacks are lifted and they look very odd and unrealistic. And this is actually not such a performant camera. It's not like so differences between this camera and this camera is the dynamic range and the bit depth, of course. This format here, it's already compressed. It's an AVC Sony format, and it's the sensor is not such a performant one. It's a mirrorless camera, and this one is a Blackmagic Design 6K RAW format. So they pretending the manufacturer is pretending it's having 16-bit color depth, instead of or comparing with this one, which is having 8-bit XAVC codec. So of course, comparing it on the small screen doesn't say anything. The problem is when we let's say save these files, export it on whatever full HD format we want to show it in MPEG-4 or whatever, and then screen it on the bigger screen, which can be even a television or even worse on a cinema screen. Because when the signal is spread on a bigger screen, you can see better the details and how the color are rendered, and the texture, and the blacks and the whites and the highlights. And that's the main difference between how the quality of the camera can make the picture look better or worse. In this case, just by having, of course, higher resolution on here. Here we have 6K. Here we have HD. Just as you can see here, it's called the codec. It's H264, which is actually the HD color space, H264. And this one, it's a raw format, which is converted here through the values, and not sure if it's, I can okay, so this is we can also have and apply we have a lot of LUTs here, and we can choose in between them and look at them, how each of these will render the background, the highlights, the shadows. This is one of the approaches when we start the color correction site, so we can do whatever it is. So this is the Blackmagic 4K Blackmagic broadcast. So there are a lot of cameras here included in this cinema film, Blackmagic film, Pocket 6K. So this one is the camera I shot it on. So the color gamut and the look we achieve through this, instead of just not using it, it's not such a different one. But again, we can start from this one, not from scratch, and change the values. After all, you see the biggest difference is in the level of the blacks. So the blacks are different here than here, and this is one of the approaches when we start the color correction session. We can choose whatever we want to choose on this LUTs gallery, and then apply it to the picture. Sorry. Okay. I think some of those approaches I already explained in that video. You can also see it or see it again if you didn't see it. But they're not very complicated. This software is very intuitive. It's easy to work with, because if you have the top, let's say how the things are working on digital capturing, and you know what we expected when we change the values on highlights, midtones, and shadows, and how the balance or the unbalanced picture it look like. That's going to be very easy and intuitive way of working with Blackmagic with Resolve. Otherwise, it is, as I told you, it's not a very complicated one. It's easy to use, and the results are very nice and pleasant. Of course, there are much more different software of color corrections, and some of them are very expensive, but they're not, of course, for consumer use. They are just for professionals. But this this software, it's I think enough for every one of you to try it and try for free the whole thing, like experimenting something with a picture you already shot it. So I think it will be fun if you'll start to do that, because you have a lot of testimonials on the web regarding how to adjust the levels, how to balance things in Resolve, and how you can export the files and then load it on the internet, and most of those are very, very handy and easy to work with. So I wish you good luck on working with Davinci Resolve, and being free. Of course, it's a nice, it's a big help. It's not like the photo software, which the one I showed you, Aperture. It's not for free, but there's some free versions of I don't know what, Photoshop is not for free, Lightroom is not for free, Aperture is not for free, something. I think there's some software on color correction and adjusting the levels on photograph on the web, but not on such a high level of doing stuff like adding or making mask or changing the inside elements, or keying parts and replace them. But I'm not sure you really need those kind of things. So I think as easier it gets, the better it is. Well, we just get to the end of the 7th class, which is a good thing. That's a great news for everyone, for me too. And nice meeting you again. And I hope it was at least not all the time, but sometimes interesting. And hope to see you, who knows, next time live in Chisinau, or whoever you are based on, and hope to chat live next time, which is going to be more pleasant than through these Zoom conferences. Okay, so take care. Nice meeting you, and hope to see you, as I told you, hope to chat next time live, and see you. We'll keep in touch anyway. Thanks a lot.
Thank you very much.
Bye. Cheers. Have a nice afternoon and a good weekend.
Yeah, you too. Thank you.
Thanks. Bye. Cheers.
And don't forget about the homeworks, the assessments.
Oh, the assessments. Yeah, you have to do the assessments. Right. I forgot about it. But you'll find it on the platform. Okay, yeah. And the quizzes and all those different things. Okay. Thanks again. Yeah. Thanks. Cheers.
Cheers. Goodbye. Bye. Thank you.
Welcome.
Bye. Thank you.